All right, welcome back. Week 6, CIT 15, video number 2. We're going to talk about the textbook, chapter 6 in this video. And, it's an interesting chapter, the title of it, Understanding and Assessing Hardware, Evaluating Your System. It's definitely something you want to be able to take away from this class, is knowing a little bit about the different terms that are out there when you're shopping for computers. And so the objectives of this chapter are describe the changes in CPU performance over the past several decades. And so we've already looked at that, Moore's law, and how the transistor count doubles every 18 months. So we're going to see that again. And we're going to compare and contrast a variety of computing devices. So we'll look at different types of computers that are out there. Describe how a CPU is designed and how it operates. So we'll see some of the basics of CPU design. We've already looked at that. It has the registers and cache and the arithmetic logic unit and the control unit. I don't think we talked about that yet. And just making sure I'm recording. Anyhow, we're going to see that. We're going to describe tools used to measure and evaluate CPU performance. And so that's like, gigahertz, right? How many cycles, how many things does a CPU do in a second? And discuss how RAM is used in a computer system. We've already looked at that, but we'll look at it again. Evaluate whether adding RAM to a system is desirable. And classify and describe major types of non-volatile storage drives. So we've heard about volatile, non-volatile. So non-volatile would be secondary storage. Evaluate, remember, hard disk drive, solid-state drive, optical drives, CDs, DVDs. Evaluate the amount and type of storage needed for a system. You're going to be doing video. You got to store a lot of video files. You're going to need more. Describe the features of video cards, features of sound cards. Describe steps you can take to optimize your system's reliability. And discuss how to recycle, donate, and dispose of an older computer. Good stuff. So the one thing I really want you to draw to mind here is the diagram where we drew it out on the whiteboard. And in that diagram, we had like the CPU, and inside the CPU this is computer remembering, right? Inside the CPU were the registers and the cache, right, where we could remember stuff. And then right next to the CPU is RAM. And then all this stuff over here is volatile. So if power goes out, you lose it. And RAM is also known as primary storage, random access memory. And then you come over a little further and you got secondary storage, which is non-volatile. And that's magnetic, optical, and solid state. So magnetic will be a hard disk drive. Optical will be CD, DVD. Solid state would be a solid state drive or flash drive, right? And that's secondary storage, and it's non-volatile. So power goes out, and the computer remembers that. And then we also had ROM down here on the motherboard. And ROM is read-only memory, and on ROM is stored BIOS. And ROM does remember what's there. It's also known as firmware, right? And so it gives you your basic input-output system. When the computer starts up, that's what tells the computer how to start talking to secondary storage and load the operating system off of the hard disk drive or solid-state drive, right? So that's kind of like that computer remembering. And when you're over here near the CPU, so registers, cache, RAM, they store less, but the access is faster. And when you're out here in secondary storage, you can store a tremendous amount, but access is slower. Okay, so computer remembering, and that's important. We're going to see that here coming up. First, though, there's Moore's law and how transistor counts have increased over time every 18 to 20 months. Every 18 months, transistor counts have doubled, and so that's good to know about. And then there's a bunch of different computers you could choose from smartphones and tablets to laptops and desktops. And then inside the computers, we have the CPU. It's located on the motherboard. Central processing unit. It processes instructions, performs calculations, manages the flow of information. And Intel and AMD are manufacturers of CPUs. Motorola is also. One of the things which was kind of shocking to me when I was learning about this stuff was that CPUs do really basic transactions. Like, at the most fundamental level, what a CPU is doing is basic math, addition, subtraction, multiplication, division, and comparison. Right? Is this greater than or less than? Is this equal to? Right? So that's kind of like the main things the CPU does, and everything kind of flows from that. It's just basic calculations. You could see what kind of properties are in your computer, and we already looked at this, but you can see what kind of properties are in your computer by going to your computer And I just opened Windows Explorer here, and here's this PC, and I could right-click this PC and choose Properties. And then it's going to tell me, you know, what kind of processor I have and how much RAM's installed, and, you know, if it's a 64-bit operating system. So that's seeing the properties of your computer. And then inside the CPU goes through something called a machine cycle, fetch, decode, execute, store. And so it fetches stuff from RAM, it decodes it, right? And then you can see the control unit is determining what gets fetched. It gets decoded and stored in registers. And then there's the arithmetic logic unit where it does the basic mathematical operations, including comparison, greater than, less than, equal to. And then that's the execute, and then it stores it. And then there's two main units on the CPU. It's the control unit saying what needs to happen when, and then the arithmetic logic unit that's doing that addition, subtraction, multiplication, division, and comparison. Really doesn't mean much, right? Like, it just magically works somehow, and you really have to take many classes to understand kind of what's happening in CPUs and the entire process of how machines do processing. Machine processing is a big thing to wrap your head around. So CPU's processing, but that's the introduction to it, right? CPU's processing power is measured by clock speed, and so that's the gigahertz. And so you could think of gigahertz as how many times can it do one of these things. So fetch is one thing, decode is one thing, execute's one thing, store is one thing, right? So we just did 4 things. Well, a 2.4 gigahertz machine could do 2.4 billion things a second. 2.4 billion things a second. So it's pretty amazing. And that's known as the clock speed, 2.4 gigahertz. And when you saw me look at my computer's properties, right, this is 4 gigahertz. So it's doing 4 billion things a second. 4 billion things a second. That's the clock speed. So it's one of the things you look to see, okay, how powerful is this computer? How fast can it go? How many things can it do a second? What's the clock speed? That's one of the things you look for, is that clock speed right there. You could overclock. You could say, no, I want my computer to go 4.2 gigahertz, but that's going to burn up your CPU faster. And if you set it too high, it'll literally burn up your CPU. Your CPU will get too hot. It'll burn up. Cores, you could buy one CPU that actually has multiple CPUs in it, and so it's known as dual core, quad core, or 8 cores, right? So if we go back and look at the properties, I don't know, I could look up this i7 CPU, i7 6700K, i7 6700K cores, right? And it's a quad core, so there's actually 4 CPUs in there. And so the benefit of a quad core is you could, you know, have 4 threads running through simultaneously. Hold on. Okay, we're going again. That was actually somebody from the class needing help. Maybe it was you. All right, so now we were talking about clock speed and overclocking and multiple cores. And when you have multiple cores, you can do parallel processing. So parallel processing is like, you know, things being processed at the same time going through multiple cores, right? As opposed to synchronous processing or serial processing where it's all just going through one core, right? And you're switching what's happening. So like if I was running 2 programs with one core, I'm running a recording device, I'm also running a web browser. Like the code for that's going through one processor. So it's serial processing, right? It's one after the other. And so it's just switching between doing the recording and the web browser, but it's going through one core. If I have multiple cores, you know, I could have the recording going through one core and I could have the web browser processing going through one core, and they're going through different cores in parallel. So that processing is occurring at the same time. So that's parallel processing. And then we already learned what cache memory is. So when you evaluate a CPU, you're looking at what is the clock speed, right? If you really need video recording, gaming, you want a higher clock speed. If, you know, you're just doing web surfing, you know, getting a Google Chromebook or something at Costco, $300, $400, totally fine. It's lower clock speed. You want multiple cores if you're running a lot of stuff, right? Recording, editing, video, doing things on the screen, right? Multiple cores, so you could be processing in parallel. You want more cache memory if you're doing more powerful stuff. And then you want, well, you could benchmark your CPU to see what it's doing, or just look at the properties of it. And then you want more RAM memory, like the more powerful the stuff you're doing. The video editing, you got to hold big video files in memory while they're being edited, so you'd want more RAM. And that's volatile, right? We already talked about that. And then read-only memory, we've already talked about its role. And then here is kind of their representation of computer remembering that I've talked to you about, where, this holds less but faster access. This holds more but slower access, right? It's kind of their picture of it. And then just so you could kind of visually see where those different those different places for remembering stuff are located on a computer. Inside the CPU, you have the registers in the cache, and it's L1, L2, or L3 cache. Just, you could have multiple levels of cache, or one. Here's like RAM, right? And then here would be your solid state drive, and here's your hard drive. So what this picture, and here are your optical drives. What this picture doesn't show you is like that computer remembering diagram, right? We kind of laid it out in a visual way, that the stuff out here in secondary storage, the solid state storage, the magnetic storage, the optical storage, that's farther away from the CPU. In reality, right, like the hard drive's right here next to the CPU, but actually to get stuff off of it, it's as if it's farther away, right? So that's kind of the thing there. RAM, you'll hear about DDR3, 4, 5, more is newer. And the memory module is just another way to refer to RAM, so you'll sometimes see the little chips on top of RAM chips. And dual inline memory modules, they'll be on both sides of the RAM chip. Resource monitor is interesting. You could type into your little search bar in Windows resource monitor. And so I just brought it up, and then it shows you kind of how your CPU is working, and CPU, and right disk, and how much is being processed of my CPU, and network usage, and memory usage, right? So, you could see what here, you could just kind of dig around in there. It's kind of an interesting thing to look at, resource monitor. And you could install more RAM in your computer usually, but you want to consult with somebody if you're new to it, or just look to see what kind of system you have. So maybe I have Dell Inspiron, 1500, 3000 RAM, right? RAM upgrade. And then I could start to see what kind of RAM is sold for that system. But you might also just open your machine up at that point and look to see what kind of RAM is installed in there, and find that number, because you kind of want to match it. If it's like, the stick is 8 gigabytes, you want an 8 gigabyte stick to match it when you put in the new ones. It's just kind of a rule of thumb. And then we looked at hard disk drives having multiple platters and read-write heads, so we've already seen that. And then we talked about solid state drives already, so you can pause the video and read this if you'd like. And like here you could sort of assess how much storage you need. 345 gigabytes, I don't know, gives you a little bit of a ballpark, but pretty much terabyte drive. It's good to get a hard disk drive with at least a terabyte, and then a solid state drive with like 256 gigabytes or 512 gigabytes. So your operating system's on your solid state drive, loads fast, and then your hard disk drive, you could store just like whatever you want out there. And then connect everything to the cloud, like all your pictures and everything. It's all getting stored on Google Drive these days. Let's not talk about RAIDs. You can read about it. So storage, mechanical hard drive versus solid state. You could pause this and read about it. Or you could have both, right? So that's what we just talked about before, and just talked about that a little bit. And then you can put in a video card. So this helps with video processing, helps you with video editing, helps you with video games and movies. And if you plug that in, you plug it into an expansion slot, and then it'll have additional ports, a display port, HDMI port, or digital video input. What's that stand for? I can't remember. But then you could plug in additional monitors, or you could have two monitors. Like I've got two monitors here facing me. And it'll help you with video processing. And so here you can see if you have a CPU and a GPU, all of your graphics processing is going through the GPU. Speakers, you know, put speakers on, you get surround sound, Dolby 7.1. And then keeping things running well. Keep antivirus program running on your computer. Usually by default it's running in Windows, along with spyware and adware. Clear out unnecessary files. You could run disk defragment or automate key utilities. And you could restore the system, right, if your system crashes. That was a good thing to learn about. And you know, if your computer's 5 years or older, it's time to get a new computer, generally speaking. And then when it's time to recycle a computer, you know, you want to make sure that you either donate it or recycle it through a certified recycler, because there's dangerous metals in computers. If they get into the soil and groundwater, it's not good for us. So that's chapter 6. Pretty good stuff. You don't need to know all of it. We kind of glanced over a few things there, but it's also there's good material in there. Thank you for joining me on week 6. Keep going, keep going, keep going. Don't give up. Maintain that grit. Just keep showing up. You're gonna get stronger. You're gonna get better. You're gonna learn stuff. You're gonna advance. Just keep going. Keep doing it. And I just realized the entire time I was doing that, dang it, I wasn't showing you my screen. So you can open up this PowerPoint presentation. Hold on. Control-Shift-T brings it back up. Control-Shift-T. And where can you download this? So this is in course materials. And I go into course materials in my T-Lab and textbook PowerPoint. So you can download that. So as we're going through, as I'm going through those, you can watch those PowerPoints. Yeah, sorry about that. All right, see you next time.